Now let's see about the select query. So selection is the basic query in DBMS in SQL. So if you see select, it is used to retrieve data from the database, and the syntax is like this: select, some attribute list is going to be given there, from some table list will be given here, where some conditions will be given, right? So we shall see the simplest versions of writing the select here, and later we shall extend it with complex queries, like there will be nested queries and all. So later we shall see that, but this is the simplest way you can write the select. So select attribute list from some tables where some condition is given. And now what is this attribute list is? This is the list of attributes whose values are to be retrieved by the query. So if you compare this one with relational algebra, there the projection is equal to selection here, right? So there you have written pi projection, right? So whatever attribute list you specify to be finally available in the output, there we have used projection, and here you are going to use selection for it, right? And next one is table list. Table list is how many tables you are using in this query to retrieve the information. Sometimes if everything is present in single table, then we need not use many tables. Sometimes what happens is, in order to get some information, we might have to join more than one table, right? In that case, we are going to apply some list of tables here. Now whatever list you apply here, automatically a join will be taken for all the tables, and then we are going to apply a selection based on where. Okay, and now condition. So the condition here, conditional expressions that identifies the rows to be retrieved by the query. So how does it work is, if you compare this where condition, it is exactly similar to the selection condition that we apply in relational algebra. So if you are thinking about relational algebra, since we have already seen it, we can compare these three. So one is select can be compared to projection, pi, and then where can be compared, here this where and these conditions, they can be compared to selection, because we are going to filter out some of the rows, and this from table list, it can be compared to the join, right? So again the join conditions will be written here. So in raw form you can think of it as if it is a Cartesian product. Got it? So how will this query be implemented is, in general, you take all the tables from here. If you are not using any optimization is different. In general, how it will be done is, you take the Cartesian product of all the tables present in this list, and out of that you are going to filter out some of the rows based on this condition, and whatever is remaining on that you are going to take the values from the projection. Got it? So this is how it is going to be implemented. Cartesian product first, then selection, then projection, right? Okay, let's see some example here. Now let us say we are going to use these two tables. So one table is department table, which is containing attributes department ID and department number, and other table is employee, which is containing employee ID, department, employee name and job, and the department number in the employee is actually referring to the department ID of the department. Okay, and now if you want to retrieve, see the query is like this. So what you want, the information is this: retrieve the names of all the employees who works for department number 1. Now we want to find out the names of all employees who are working for department number 1. So if you look at this employee table, it is containing the entire information, which means in this query we need only one table, right? So if you look at the employees who are working for department number 1, this is the only employee who is working for department number 1, right? So this one. And now you want to list the names, which means this is what you are going to get, right? So what does from contain in the select query? What does from contain? The from clause is going to contain the table employee, because this is where you want to get the information from. And what is the selection condition? The selection condition is, whenever department number equal to 1, you are going to select such rows. And what is the final projection you want? In the select clause you are going to write employee name. Got it? So how to put it in the query is, see this: select employee name, which means we are finally going to project EMP name, right? From where? From the employee table, right? From the employee table where department number equal to 1. So it will take this employee table and then apply the selection condition, which is department number equal to 1. Based on that selection condition, it is going to filter out this one, this one, this one, this one, this one. All of them are going to be filtered out, and whatever is remaining, on that we are going to project whatever we need, right? So what is that we need? Only the employee name, which means we are going to get Santosh as the output. Got it? Okay, next one is retrieve the names comma employee ID of the employees who work for IT department, right? Now if you observe this, here we have only department number, but we don't have anything specifying that it is IT department or anything like that. So the required information what we have to display is names and IDs, right? So name is here and the ID is here. This is what you want to display. But then in order to display this, you have to find out the department IT. So that information is present here, IT is present here. Therefore, whenever you have two tables, you are supposed to join them and get the required attributes, right? So how are you going to join is, first you are going to apply the Cartesian product, and then on the Cartesian product, you have to match every employee with the corresponding department for which he is working. For example, if you see this, if you apply Cartesian product, then this record of employee 1 will be matched with all of them. But then what we want is meaningful data, which means this particular employee has to be matched only with the department number 5. So how are you going to take that? There we are going to apply a selection condition, which is going to filter out the unnecessary rows, right? So since it is going to be matched with all of these, if you apply the join, now you have to write a condition so that it will filter out all the remaining, and only this one has to be paired with this one. Got it? And similarly this one has to be paired with this one, right? So how to see that is, see this. Now this is nothing but the projection. So select employee ID and employee name. Why only these two? Because that is what is asked, names and employee IDs. That is why only these two. From where? From these two tables, employee and department. Now why these two tables? Because required information which you want to display is in this table, and then the department name is in department. That is why these two tables. Now whenever I write from in some tables, it is nothing but we are taking the cross product of or Cartesian product of these two tables, which is going to give us lot of tuples. Now out of all these tuples, you have to filter out meaningless tuples, right? So what are meaningless? Combining this particular employee with any department other than department number 5 is meaningless for this query, isn't it? So you have to combine this employee with only department number 5. So in order to see that it happens after Cartesian product, you are going to apply this condition. So in relational algebra, this is the join condition, right? So what is the condition? Department equal to department ID, which means after Cartesian product, join only the tuples which are having matching these two, which means this one will be matched with this, and this one will be matched with this, and this one will be matched with this. See, this department 1 is 1, right? And this one is matched with this, and this one is matched with this, and then 3 is matched with this, right? Which means you have to visualize it as if there is employee data, and to the adjacent to that there is corresponding department data. Now how many tuples you get is, after running this query, you are going to get the number of tuples equal to the number of tuples which are present in this employee table. Every employee will have will be joined with the information of the department for which he is working. Got it? And now out of that we need only the entries which have department name equal to IT, right? So which means only 2, this one. So wherever you are having this matching, you are going to take this, right? So if you observe this one might have been paired up with this entry as well as this entry, right? So only these 2 rows will be selected. Got it? And now what will be printed? The final print will be employee ID and employee name. So corresponding to these 2, you are going to get employee ID and employee name, which means 2 comma Srinivas, and then the other one is 4 and Soumya. So 2 and Srinivas and 4 and Soumya will be printed. Got it? See, this is the way generally your search engine is going to work, but if you try to optimize it, right, you can still optimize it further. So depending on how can you optimize it is, first you filter out this table based on IT department, and then you join the resulting with this. That is one other way of doing it, right? Let's talk about the optimizations later. In fact, we don't have optimizations in GATE syllabus. So okay, so let's not discuss about it. I mean, optimal way is first filter it out, make it small, and then join with the corresponding table and you get it. But then anyway, it is not in the syllabus, the implementation of the DBMS. So this is the way it is going to get executed in general. Okay, and the next one is retrieve the jobs of all employees. Now we have to retrieve the jobs of all employees. So where is the information present? The jobs of all employees is present here, isn't it? This entire column. So it is simply a projection, isn't it? In case of relational algebra, it is simply a projection. But coming to SQL, a projection is equivalent to select. Therefore, we are going to write select job from employee table. That's it. Because the entire information is present there. You need not write anywhere because we want everything, right? No discarding or no selection is done. That is why we are going to write everything without where. Now, if you observe it, the output is going to contain some duplicates as well, right? The entire data whichever you get here will be displayed. Now if you observe this, there are duplicates. The main difference between the projection that you have used in relational algebra and the selection you use in SQL is that in projection or in relational algebra, everything is a set, right? Everything we talk about is a set. A relation or a table is a set of tuples, right? Therefore, whenever you talk about a set, there you don't have duplicates. That is why in this formal language, relational algebra, when I am using projection, there will be no duplicates. We discussed about it there anyway. So no duplicates will be given. But then SQL is not a formal language, it is a practical language, right? And if you are using select, both are exactly same, but only difference is that select is going to give you duplicates as well if there are going to be any duplicates. Now why is this feature implemented is, even though it is costly, see, eliminating duplicates is costly. You have to find out that there are duplicates and then you have to eliminate it. It is extra work, right? But still, even though it is costly, why we implement it is, so eliminating duplicates is costly, so we don't implement it, right? So why we don't implement it is, first thing is it is costly, and the second thing is sometimes user wants to see the entire information. He don't want the database to eliminate any information. For example, if you want to count, then if you eliminate the duplicates, the count is going to be different, right? Or if you want to find the average, then some of the values will be missing, right? Therefore, in some cases, user want to see the data completely with duplicates, and also eliminating duplicate is a costly operation which is not required unless user is specific about it. So that is why we are going to have one more clause, distinct. When distinct is added to select, then whatever output select is going to give, from that duplicates will be eliminated. For example, if I write the same query by using distinct keyword, then if I use this keyword, this particular duplicates will be eliminated and I will be getting the output without duplicates, right? So you have to remember that relational algebra projection is equivalent to selection. Only difference is that here no duplicates will be allowed, here duplicates will be allowed. Got it? Okay.